Now then, crew, welcome back to the Andy Mechanic YouTube channel, and my apologies, it's been a few months since the last video hit the channel. The reason for that is we were building the workstations, and then we did the new roof on the workshops. It's nice and dry in here now and a lot cooler. And of course we built an extension to give Ben, my lad, his own shed. So I've been really busy on weekends, and I just haven't had the time to film. We did do the odd live stream every other Sunday, and that's helped me to keep in contact with you, the viewers. But now it's time to get back to making some videos. Now, recently I've been using the welder for a few little odd jobs, and I've noticed that the wire speed on my MIG, well, it hasn't been quite right. It keeps jumping around without moving the dial. Sometimes I come to use the MIG and the wire speed is really fast, other times it's really slow. You move the dial up to increase the wire speed and it slows down. You move it down sometimes and it speeds up. It's just ad hoc. You can usually sort of jiggle it around and get it to sort of be about the right kind of speed to get the job done, but it's a real pain. So I went online, and my welder is a Murex 251 single phase welder. It's a commercial spec welder. It's designed for industry and it's been absolutely brilliant. I've owned it now, well, since about 1997, 1998 would be about that time I purchased it. So it's what, about 27, 28 years old. It's been brilliant. The only other problem we've had with it is the earth clamp, which is essentially exterior to the MIG itself. That wasn't gripping the steel very well and providing a strong enough ground, so we had to replace it. And after that, it was fine again. We've got a brand new power supply into the workshop now, 40 amp single phase supply into the workshop, so it's got a really good dedicated power supply, which it needs. It draws about 38 amps under full power. It's a bit of a monster, really. So I went online to do a bit of research and to see if I could still get parts for this old Murex Mig, and unfortunately you can't. The company's closed down. They don't produce welders anymore, which is a terrible shame. And I was sort of doing a bit of research about what this problem could be. You know, is it an issue with the circuit board? Is it an issue with the motor? You know, the wire speed motor that runs on the two little rollers? Or is it something else? And one of the things it could be is the potentiometer. That's the actual dial on the front of the MIG, which you dial up or down depending on whether you want to increase or decrease the wire speed. That seems to be the most common issue, and to be fair, you know, being a potentiometer, it obviously is going to be a wearing part, and well, it's been there for 28 years. It's done pretty well, and it's a relatively cheap part to replace. Although I can't get a genuine part anymore. Just not available. Might be able to find a second-hand one, but at the end of the day, it's just a potentiometer, and you know, I may well be able to source one locally from a, I don't know, J-Car, for example, an electronics supplier here in New Zealand. Okay, let me get the MIG fired up and try and demonstrate to you what the problem is. Here we go. Used.
You don't paint something without wiping.
Honestly. Okay, let's set the wire speed to about just before 6, because we're on power setting 4 on the high setting. As you can see down here, we're on number 2. So that's high and low. So low, high, 4. So it's about just before number 6 on the dial is where I'd usually expect that to be. Right, let's do a weld. Now this might work brilliantly, or hopefully it'll be the wrong line speed, either way too fast or way too slow. Only one way to find out. I'll weld that way, I'll weld towards you, how's that? Oh, that's perfect! Bloody welder. Right, I'll move it a bit. We'll give it a bit of a wiggle, and then we'll try again. Okay, we're on my other phone now, so we're about 5 3/4, so we're just going to wiggle it around a bit, put it back on 5 3/4 and try again. Jeez, we're going to take it down a bit. Okay. That's too slow. We'll give it another wiggle. This is the problem, it's really erratic, it's not always a problem. Oh well, I think you get the idea. Well, as with all videos, not everything goes to plan, and with this being an erratic, irregular fault, it was only played up once on camera. Now, it could be the potentiometer, it could be a fault on the board, it could be a fault with the motor. At this point in time, we just don't know. However, the information on the forums leads me to believe the most likely issue is the potentiometer. So, let's get the MIG turned off at the mains, unplugged so it's all safe. Hopefully there's no big capacitors inside. And then we can locate the potentiometer and remove it, and then we'll do a quick bench test, and that will prove whether there's a problem or not. Okay, I've disconnected the MIG from the power supply, so we should be all good. Never go inside a live welder, that's for sure. Lots of nasty electric inside there. Wow. Holy moly, look at all the cobwebs. This thing is has 27 or 28 years of build-up inside here. But I can't see anything burnt, which is always a good sign. It doesn't smell burnt either. And I mean, to be fair, it's probably done a lot less work with me than it would have done if it was in industry. Mind you, saying that, it would be scrapped by now if it was an industry machine, probably. But yeah, what a state. Needs a good blowout of the airline, doesn't it? Wow. Look at this. Some of these dials, these bottom two here, look, they've been put in bags at the factory to keep the dust out. That's cool. You wouldn't see that these days. Wow. It's even got a circuit board, look. Okay, so the dial we want is this little bugger here, look, line speed, wire speed. So if we go around here, there, that one. Okay, so can we just pull the knob off? Yes, right, the knob's off, it's on like a little spline by the looks of it. Okay, so we've got a nut to undo, and then we should be able to pull it through the casing. And luckily there's some little connectors just above it, so we can unplug those, and then we can bench test that potentiometer. And there's no hiding from a bench test, is there? Okie dokie. Hopefully I will get a shock. I'll let you know if I do. Way, spider! What the hell? Okay, don't do spiders at all. Very, very pleased with this MIG. They say the Murex MIGs are one of the best welders you can buy on the market, and they're quite sought after now because you can't buy them anymore. Okay, right, we've got a little washer, little spring Barbie washer thing on the inside. Remember that? We'll need to refit that. 3 wires, red, yellow and black. So we'll just unplug those. Jeez, that's 1, 2, 3. Right, to the bench. Oh, and where's the knob? We're going to need that as well, aren't we, to control it? Perfect. Right, a couple of fly leads. And multimeter. Okay, I'm trying to get all this in the camera shot for you. So, we'll stick the yellow lead on the negative. We're going to be measuring resistance, so that's quite easy. So we'll put the meter on 20,000 ohms, 20k resistance. So we've got black onto the yellow, and for your reference, red onto red. And make sure that those leads don't touch. Okay, so on a potentiometer, normally the middle wire is the common. And then you've got inside here 2 tracks, so that as you turn the dial, the resistance of one of the outputs, which will be, let's say, black, will go down, and red's resistance will go up. And then when you turn the dial the other way, the opposite happens. It probably gives the machine a bit of a fail-safe, so it should see one reduce as the other increases and vice versa. A bit like a TPS on a vehicle. Okay, so we'll put, oh, I've got yellow, so we'll use yellow as yellow, just coincidence. So we're going to put the negative onto the common. It makes no difference when you're checking resistance. And let's put red onto red and see how that one fares. Okay, so you can see on the multimeter we've got 8,920 ohms of resistance. So if I turn this dial, I'm going to turn it around so we're looking at it head on, and we're going to turn it fully anti-clockwise, which would be, okay, well, absolutely nothing is happening. What is it? Is it in mesh? Maybe I didn't put it into mesh. Hang on. There, we're in mesh now. Okay, we've got to turn it anti-clockwise. There we go. And so on the red lead, these are not touching, by the way, they're insulated. If we go back up, so the maximum, oh, that was 17 then, jeez. Okay, so that one, as I turn it clockwise, that one goes down. And what we're looking for is a jump in the reading. So 8.7, it's going to go really slowly. It's not really, oh, it's going down again now. And now it went up, now it's going down, down, up, which is wrong. It should be only going down. Oh, look at that. So I'm going to go back a little bit. So we went from 8.4, keep turning it clockwise, 8.3, going up again, 9, 10, 13, 12. Oh, it's all over the place. Overload, and then nothing. Okay, so that one starts high and goes, in theory, goes down in resistance. So if we move the red wire, which is our positive terminal, positive probe, and put it on black, this one should go up from the start point. So not quite know where the start point is. We sort of just got to find it. Okay, so just over 1 kilo ohm, so 1,000, well, exactly. Look, just dropping a little bit. And this is another fault. It should maintain a set figure. It shouldn't be jumping around. So we're at 0.92, 1, 2. Okay, that's a good start point. So as I turn the dial clockwise now, this figure should increase. And I'm going to try and do it really slowly because we're looking, oh, look at that. So it's only moved a fraction. It's already at 7,000 ohms. Then it's dropping down again. .8. I'm going to go the full cycle. And then it sort of gets stuck. An ohm, 1,000 ohms. 1.4, 1.6, 1.7. There we go. Okay, so I get jumped straight up to 7,000 then. You see that? And overload 13. Okay. This is not good. It's not good at all. There's something significantly wrong. Probably worn out tracks or dirt in there causing a problem as well. So we'll disconnect that. We'll turn the meter off. That has failed. It's junk. It really is. It's just maybe worn out. There may be no poor contact between the track. And do you want to have a look inside? I bet you do, don't you? Let's have a look inside. I'm keen to have a look inside. Okay, don't know how successful this is going to be, but we'll give it a go. See if we can split that open. Yeah, we've got some movement. Way. Okay, here we go. Now it's destroyed, isn't it? So we've got... Oh, yeah, there you go. Look, you can see my little pointy stick. You can see the yellow comes in, and we've got the common track around here. And then we've got here a couple of tracks running around the outside onto the red and the black. Looks like a carbon type track, doesn't it? I'm no electrical engineer. Okay, and then here we've got the three little prongs. So this one here, the closest to the center, will run on the yellow track here, going around there. And then we've got these two prongs here, which will then link to these two respectively. Now, it might look on here that these two tracks are connected, both of them are connected to both of these two terminals. I don't think that's the case, because it wouldn't work. One would need to be connected to one side, say the black, and one connected to the... Otherwise, there would be continuity, wouldn't there, between these two, which I don't think there is. Let's have a little look. Where's the beepy beep thing on this thing? There we go. Right, we're on beepy beep. We'll get rid of our little fly leads. There we go. We're sticking down there. Have we got continuity between these two? No. Oh, sorry, camera. No, there's no continuity. So, one track, basically, the flow of current would be from the center to, across on the pin and onto one of these tracks and out on the black, and then from the center to the other track and out on the red. That's basically all it is. Very, very simple piece of kit. However, it's junk. It really is. In fact, it's even got two little contacts here. Look, one there and one there. I didn't see that other one. Most bizarre. Okay, let me go and find a replacement. There's one. Excellent. Nice. Now, to be fair, I was hedging my bets on it being this component. And to be fair, I was going to replace it anyway, because it is a wearing part. And we've found a problem. If replacing this doesn't fix the issue, or it still raises its ugly head now and again, then I know that there's another problem. Maybe it's with the board or with the motor itself, because again, the motor that spools the wire is also a wearing component, and it might need to be replaced. So let's just measure this one and see how it looks. I know that this is a 10,000 ohm variable resistor potentiometer, and it's of the linear type. So if you do need to replace one on a MIG, it's normally the linear type that they use. And I went to a local electrical place, JCar in Auckland, actually no, New Plymouth it was, and said I need a 10k linear potentiometer, and that's what they gave me, and it was $7, so hopefully it'll do the trick. The only downside is it currently doesn't work with the original knob. I did get a knob that will work with it. I'd like to keep this one though if I can, so I might have to jerry-rig something to make it work. I don't know yet, but that is not the issue here. The issue is this going to fix the problem? So let's get our two leads, and we will put on our little fly leads again, because I haven't got crocodile clips for the end of my test leads, which I should have really, anyway. Okay, so yellow we'll call the common again. I'm assuming it's wired up the same way. The guy said he thought it would be. So we can't do that, can we? I'll have to do it that way around. Okay, so that one is on. Let's go onto this one here first. And we'll put it on to 20,000 ohms again. So I'm going to need to move Torchy, move all this stuff, and get you the meter back into shot. Right, hang on, bear with me. There we go. Okay, so I'm just going to turn the shaft manually. Now, if I turn the shaft fully anti-clockwise, okay, there we go. Can you see that all right? Let me just move some of these wires out of the way. Things are not ideal, are they? There we are. Right. Okay, so we are fully anti-clockwise, and we are on the equivalent of what would be the red wire on the old one. Okay, so this one, the red wire started high and dropped low, didn't it? Okay, so we'll turn that clockwise as if we're turning the dial on the MIG, and what we're looking for is it should only count down and not count up, i.e. the resistance should decrease. I'm going very, very slowly. That's how you test TPS units and stuff that are like this. Basically just counting it down. If it was to jump up or jump down a considerable amount like we saw on the faulty one, then we know that there's an issue. Okay, just speeding up a little bit, counting down. And it was on the forums that I found out that it was a 10,000 ohm potentiometer, and there was a very helpful chap in the UK also at a MIG repair shop. They said they couldn't supply one, but he was pretty sure it was a 10k ohm linear. There we go, look. So we're down to 0, and we've now hit the stop fully clockwise. So what I'm going to do now is return back to our full anti-clockwise position. Move the test lead to the other side. This should now start low and go high. And yes, look, we're at 0. As I turn it clockwise, there we go. We're just starting to count up. And keep going. It should go all the way up to 10,000 ohms. That's pretty smooth, isn't it? I'm just watching the screen for any kind of glitches. I did buy a second one as a backup, just in case, because it wasn't expensive. And, you know, it can go into stock and it's there for 27 years' time. Probably for somebody else to fit. So there we go. That's fully clockwise, and it counted up nice and smoothly. So we have a winner. All we need to do now is solder on some little leads, which we can probably steal off the other one. And away we go. Install it, and it should be fixed. Hopefully. There we go. Good old Dremel torch. It'll take a little bit of time to warm up. I'm not the best solderer in the world, by the way, so feel free to ridicule in the comments. I can usually get the job done. So I'm just going to tin these 3 contacts first, and then we'll see how the how these ones are held on. In fact, while that's warming up, hold that over there. Let's pull these back and see if we can. I'd like to be able to steal these ones and just reuse them, because I've already got the right connectors on. Yes, they're just soldered, so we can desolder those. So we'll do that one at a time. And so we'll do the yellow one first. I've covered all the colours on now. We'll make it work. Okay, let's just tin these first. We should be good to go now. Come on, Torchy, you can help us out with this. Right. There we go. Okay. Ooh, that was easy. That was super easy. Flows straight on, look at that. Maybe look a professional then. Alright, that's tinned. So now what we need to do is I'm going to take the, this is the red one on the left, so let's do the red one first. Hopefully they're not crimped as well. No, they're not. Oh, look at that. Okay, so in that orientation, this one, do it to camera, this one should be the red one. So, without burning myself, whoa, that exhaust right on my finger, jeez. I reckon that'll work, won't it? It's not quite straight up, but it doesn't need to be. Although saying that, we need to get the little... Could do with a vise to hold it. Hang on, just bear with me. No, I can't crush it in the vise. It might... Yeah, it might get a bit crushed, mightn't it? Yeah, and I want to hold it flat, so the solder flows better. Okay. Let's have another go at just realigning that one without burning my fingers. It's getting quite hot. There we go. That's definitely not going to come off. Right, next one, the middle one, the yellow one. Let's just drop that one off there. That is warmed up enough. Nice. Look at that. Right, so I'm just going to pull that up there a little bit more. There we go. Okay, yellow is going on. Don't burn your fingers, Andy. Maybe I could do some pliers. Hang on. Bear with me. Back in a second. Nice. That'll save your fingers from getting burnt, might it? Plus it might help to get the angle slightly better as well. Yes. So you can't beat tools. Tools are good. Okay, is that good enough? Yeah, it's definitely flowed. Okay, that's that one. One more to go. Simple job. See if we can just pull that. No, it's not. I mean, to be fair, if you did wire it up the wrong way around, it's, you know, as long as you get the middle one in the right place, you could just swap the other two connectors, couldn't you? There we go. Okay. Just going to crimp that bit together a bit. There we go. Right, said Fred. Still on camera? Only just. Move it there a bit. That's better. Okay. Let's see if we can get that one to go on there. Be so careful where the exhaust goes on this thing, because it melts stuff if you're not careful. Okay, is that good enough? I reckon it is. That'll do the trick. Right, we'll just move the insulation-y bits down. Turn that off so we don't burn anything else. Okay, and now we just got to pull this insulation back down over there onto the solder bits. Oh, that's not too bad, is it? Look at that. Almost feel like I've cheated. But I mean, why have to find new wire when I can use the old ones? Oh, look at that, that one's split, look. Okay, well, whatever. It's not going to touch anything. Okay, so the next job now is, I think this is going to need to be cut down. We'll use this knob for now. So let's pop it into the casing and just looking at that, that's going to get in the way. It's got a little earth thing on it as well, and that's going to fall foul. So I'm just going to bend that this way. There we go. Get rid of that, because that's redundant on this one. We don't need that. Okay, so we can go and install this, pop this knob on for now as a temporary until I can work out if I can get the other one to work. Why do you make it? See if I fit that. Okay, leave that one on there. If I fit that now, I'm going to end up cutting that right down. If I decide to use this knob, I could do with it to be longer. Actually, it looks pretty good, doesn't it? It looks like it's got a little brass. Wow, that's quality, that is. It's got like a little brass insert to it. Can I get that out? Is it screwing? It looks like it's screwed in. It's definitely turning. Is it coming there? That's the question. Hey, sorry camera. Ooh, look at that. Okay, so they have a little insert that keys into there, and then like a little linking bar. Okay, so will that go on there? Probably not. So how could I could drill that through and put a nut on the outside, but that wouldn't look very good, would it? I think that's a problem for me to deal with later on. It's more just the aesthetics. What you're interested in is fixing the MIG, and to do that we just need an knob, like Mr. Clarkson would say. So, little flat screwdriver, little grub screw in there. See there, look. Right, so we'll pop that in, we'll stick that on, we'll measure the distance from the back side of here, pointy stick, back side of here to wherever the face of the MIG is, and then we know how much to cut it down, but we'll add maybe an extra, or we'll deduct a millimetre or so from that length we're going to cut, so that we have a bit of clearance between the knob and the casing. And then it'll work, it'll do the trick for now. And then with the spare one of these, I can work out how I'm going to be able to get the original knob to fit. Because I would actually like that, because, you know, I've had this MIG for a long time. It'd be nice to keep it all looking original, so to speak. Okay, right, to the MIG. Right, first of all, remember the spring washery thing. Stop it ideally stop it moving around on the back. Now, to do that, it really needs to key directly into the switch, doesn't it? And with that other washer there, it didn't. Doesn't feel like it's going to do, to be fair. It feels pretty slippy on there. So we will have to just tighten it up and hope for the best. Stick that back on there again, because it'll get a better seat on there at least. Okay, we're not going to wire it up just yet. Let's poke it through the hole. Now, do we have enough thread for this washer? Ooh, I don't think we do. But it needs a washer on. So do we have to do away with the springy thing? I think we do. So we'll get rid of that, because that was with the old switch, don't forget. Let's try that, and then Mr. Nut. I'm pretty sure it'll be fine, because they're very, very light to rotate to these switches, these dials, so I don't think it's going to turn in the housing. Okay, that's about where it needs to go. Is it the same size? Of course it's not. No, different size. Okay, well, believe me, it's in far enough for now. Okay, this is the knob, and the knob is all the way on, so we just need to measure the distance from the back of the knob to the casing, and then we can cut the shaft down by that amount, because we don't want it sticking out like that. That looks silly, doesn't it? Okay, so we've got, it's about 3.15. So if we cut 30 millimeters off that, mind you saying that, Oh yeah, it's got a recess, so the recess should hide the nut. So it should go down to about there, so maybe 30 mil off. So if we cut 30 mil off that, it's going to be about there. Yes, I reckon that'll work just fine. Okay, 30 millimeters it is. And I still haven't got an electric shock, which is great. Okay, get that washer out of the way. Boom. Okay, time for a, what should we use? A slit disc? Probably a slit disc in the vise. Hold that bit in the vise, cut that whilst holding this. Hopefully the vibration won't cause it any harm. See, it's actually quite open inside there. Look, you can almost see, you see that inside there? You can see the bits. So I might put a bag around this as well to keep all the dust out, because it's a very open, it's a lot more open than the original. So if the dust gets in there, it could cause it to fail a lot more prematurely. Yeah, it's not ideal, is it? I think a bag is definitely called for. Okay, 30 millimeters off the length. It's about there, look. Cool. And it's the side, because it's quite a wide mark, it's the side closest to the switch that I'm going to be cutting. So that mark is about blade thickness. So if I cut exactly where the mark is, we should end up with about the right length. Right, angle grinder. Okay, here goes nothing. Right, quick clean up with a file and we should be good to go. Just making sure there's no bits of metal end up inside the switch as well, because you know that's going to cause problems, isn't it? Given the fact that metal conducts and all that. It feels like aluminium actually. I thought it was steel initially, but it's an aluminium shaft, which has made it nice and easy to cut. There we go. Nice. Okay, to the Mig. Okay, it's in a bag. So I found an old zip bag and I can put the wires on once it's in. And I can, in fact I could do that now actually. And then we can put a little cable tie around the whole lot. So a bit fiddly, but I'm sure we can make it work. Okay, so black. Pop them on there, look. Okay, yellow. They're very tight connectors, these. And Mr. Red. There we go. And we can move that up there. And we can, I'm going to get a zip tie and we'll just zip tie that round there and it'll be nice and sealed. Brilliant. Very impressed with that. Carrying on the theme of what the other guys did in the factory. Okay, I reckon one of these will be the right kind of size. These are from Forge and they're a 3.5 by 140 mil. They're about the smallest ones I've got. Okay, just stick that around there. You guys see all right? Maybe I need to bring it down. Oh, there's a lot going on this bench, so bear with me. I'll turn you around like that. There you go. Okay. So, push that to one side, wrap that around like that, get the cable tie, don't want to go mad with the tightness, I don't want to stress out those solder joints, but we just need to, there we are, looks pretty good, doesn't it? Okay, let's snip that off. Better than standard, because this one, the original one, didn't have a bag around it. Okay, now we need that one on the inside, don't we? There we go. Not quite as easy to get through the hole this time because it's a bit shorter. No comments on that one. Right. Okay, so now we need one of them, and we need the nut. And of course I didn't get the right size spanner, so I will have to go and get that. Or you can see them on his fingers. Okay. Looks about right. We'll try with it. We'll line it up with the knob in a minute. Okay, we're going to get a spanner. I think it's a 12. I brought a 13 just in case as well. Looks 12ish to me, but no, it is a 13. That's why it's important you bring all your spanners. Right, we'll just give that a little... That's better. Just give it a little nip up. And we'll see where that sits. So we can pop that on. Oh, I see. We've got to do the screw up. Okay. Let's do that. Little flat screwdriver. Because it's the little grub screw that holds it on the flat. So until we put that on, jeez. Left hand's up there all today. There we are. Okay, so we're on now. Yes, we need to come lots round to the left. Geez, heaps. So I'll just double check we're on the flat. I think we are. Yeah, we were. So we need to come lots. So we need to turn about 90 degrees inside there. There's not a lot of room actually, because we've got... Oh, it's just a circuit board. It might be alright. Don't panic, Mr. Mannering. Okay, so I'm just going to rotate the whole switch. That's about as far as we can go. We're not going to be able to go far enough. So, that's just the way it's going to be. Put a different colour marker on it, that's all. And this is only temporary if I can get the other. There we go, it's definitely tight enough. Right, so we've got the flat upwards. Yeah. Yeah, it's not lining up properly, is it really? I don't think. No, and I can't go down because there's these other two switches as well, so very limited on room, unfortunately. But once I get the original knob put on, we should be fine. It won't stop it from working because basically fully clockwise is down. You know, it's just going to be like that. So I could always mark it with another paint pen, couldn't I? Let's do that, just so I've got a reference point. Okay, yellow dot is the dot we're working to, and that is there and about there. There we go. That was easy, wasn't it? Simple way to fix it. So 0, and we have, oh look at that, it's bang on. So it's got exactly the same rotational range as the original. So it stops at 10 just down there, and 0. So we should be good. We just ignore the white dot. In fact, I've got a black vivid. Talk about a bodge. Is it going to work? It is working. Look at that. It just disappears. That one's a bit harder to do actually because it's quite a there. Perfect. So now all we do is look at the yellow dot, in which case we can make it a bit bigger, can't we? So we can do that, and that'll do, I reckon. The dot marks the spot. Perfect. You'll want to have a little look inside, won't you? Okay, so we'll set it on 0 for now. And looking inside, there you go, look. All hidden away. There's the bag. It's all protected. I think the wiring's fine as it is. It's not catching on anything. It's out of the way. Hopefully it'll last another 27 years. Right, we need to test it. Okay, we'll leave it on 0 and just see how slow the wire speed really is, and then we'll start to bring it up to where we need to be, and then we'll check it right at its maximum so we know we're getting a true change in wire speed depending on where the knob is. And incidentally, how's this for a cool setup for filming welding? Now, the only downside I've found is the old welding mask that I used for the the auto darkness isn't adjustable. So I think I can make it even better with a new one, but they're a bit expensive, so it might have to wait. But you know, I'm quite pleased with that. Pretty cool. Right, here we go. Okay, power is on. There's no smoke coming out of the MIG, which is a good thing. Okay, so we're on the slowest speed setting possible. It's probably not going to like it at all. Yes, that's way too slow. I'll just burn my tip out. God damn it. Right, I'll put it up to number 1. Before I trip over the earth wire. Okay, this is setting 1. I mean, obviously it's fully adjustable, but this is where we're at with 1. Okay, a bit quicker. Okay. That actually was about 1.5. It must have moved a bit. Yeah, this is 2. Ooh, that's pretty quick. This is 3. That's a bit quicker. A bit too fast really for this welding. Okay, setting 4. Wow, that's way too fast. Setting 5. Too quick. This is setting 6. This is where I would normally have it on to weld power setting 4 on high. And that's a lot faster. Okay, gonna go again. This is now 7. Yeah, we're on 7. Way too fast. It's just getting faster, isn't it? Okay, setting 8. Yeah. I'm going to stop at that because I reckon the forums weren't correct. Bugger. Now, all is not lost. I still class that as a complete success. The MIG now works and the wire speed is fully controllable, be it in a smaller range of the dial rotation, which is a bit annoying because it's going to make it a little bit more finicky getting it right, but it will maintain the speed that I set it at. However, I think rather than being a 10K potentiometer, I think it's only a 1K or maybe a 2. Nobody's mentioned 2 on the forums. They either mentioned a 1 or a 10. Now once we got to about I'll have to check the video, but I think about setting 3.5, 4, around that mark, we were at maximum wire speed, and you never weld with that kind of wire speed anyway. So I think I'll go back to JCar, another $7, and I'll get myself a 1, exactly the same piece, but a 1k ohm linear potentiometer, and I'll install that, and I'll let you know on the live streams how it's going. I think that will suffice. It'll give me the full range of dial. Unfortunately, on the old part, the one we've taken apart, the old potentiometer, there were no markings on the outside to indicate what the spec was, and there's nothing in the operation manual or in the parts manual for this MIG. It just gives you a part number, which I think was 141172, Murex part number. How was that from memory? So hey, for the sake of $7, I don't care. It's not a problem. It's shown you how to test and how to install a new one. And obviously for your MIG, whether it's a Murex or a different brand, they all pretty much work the same way. Do a bit of research, obviously, in advance. But you know, hopefully it's going to help you out to fix yours. I'm actually quite happy with it as it is at the moment. It's not perfect, but it works, you know. And you know, when I get the 1k ohm one, I can also give it a go. I'll test it first. If it does work, then obviously I can fit the knob, the original knob, to that one, and it'll all match then. Shouldn't be too hard to do. We'll work it out. Okay, crew. Well, hopefully you enjoyed this video. It's something that I had to fix, and I thought I'd take you along on the journey with me. It's only a short video, but if it helps a few people around the world to fix their MIG welders, especially their Murex, then it's a win in my book. Now, you'll find me on Facebook, Instagram, and Twitter. Don't forget to, you know, you can subscribe to the channel. There's a little icon down the bottom somewhere to subscribe on the homepage. And if you'd like to support the channel, you can do that through Patreon or PayPal. If it's PayPal, don't click donation, because nowadays PayPal changed the regs and you have to be a registered charity to receive a donation. So just click payment and send across whatever you like, you know, $1, $5, whatever. It all goes to help make more videos in the future. If you can't afford that, that's not a problem. You know, not everybody sends through donations. If they did, I'd be a rich man, I'll tell you that, and I'm not. You can share the videos on your social media. Why not? If you enjoyed this video or a different video on the channel, and there's over 800 videos on there now, just share that video on your Facebook or Instagram or whatever, and get the word out. So let's try and gather up a few more subs for the channel, because we're not far off 100,000. I know, milestone, isn't it? Okay, crew, well, thank you for watching, and I will see you in the next Andy Mechanic video. Cheers, over and out.
And we get the
Oh!